Okay, again, welcome to the next lecture of the Linux programming and scripting. Today we are going to continue our discussion on Perl. We have seen some introduction to Perl. We introduced some data types. Uh, We went into an in-depth analysis of the scalar data type and a few control structures that we talked about. Um, so let's just do a recap of what we discussed last time. We also talked about some operators. We already covered the operator precedence. I hope you remember the precedence table because that will be used in all the lectures going forward. So just keep in mind. Anyway, let's talk about that. So in the last lecture we covered the auto increment and the auto decrement commands. Which are these plus signs, the double plus signs, and we also like saw some differences between to put the plus first or towards the end. We also saw the auto decrement, which is actually the negative commands, and again we saw like how they can be written in Perl and how various things will be interpreted differently. We also talked about the chop and the chomp commands. The chomp command is a command that is used to remove the new line character from the words essentially. We saw that and then we took several examples as to how to use the chomp function, which is pretty much like used everywhere today. Like as soon as you read the command, read any line from a file, you want to chomp and get rid of the new line characters at the end. Then we talked about some of the scalar interpolation. Basically, like once you have a scalar variable, how it is interpolated within a command, within a print statement inside Perl. We will talk more details about this in the next slide. We also talked about the stdin, about how that functions. We briefly looked at this $/ as a delimiter basically, and then how we can use it to read multiple lines from a file or multiple lines from a standard in input. And then finally we also saw this undef essentially. So I'm going to actually take some more details about these three, like just what we talked about last time. In case the last time what we didn't pay attention to. So let's look at the interpolation of the scalar variables. Mainly we talked about the rules governing this. The variable interpolation occurs inside a double quoted string essentially. So this is one of the differences that we saw in the previous lecture, where if the difference between a single quote and a double quote, and if the variable has not been assigned a value, then the variable is replaced with an empty string. So that's another key differentiation essentially, or key way to distinguish. So the program will not generate an error. Instead, it will basically replace the unassigned value with an empty string. One other thing is like there is no double substitution, meaning you cannot substitute once and then have that as another variable so that you can substitute it again. So it is only one time use essentially. So that's another thing. Then in case like you have letters basically that are continuous, and then part of it denote a variable, then you can use these the brackets essentially to separate the variable from the surrounding text. This will be more apparent when I talk about this next rule, which is right here, which is the longest possible name will be used as a variable in a string. So if you say like, okay, my name on Iyer, and then you put a $, this whole thing is treated as just one variable at this point. say like you want to actually the variable is dollar $Anand, and then there is higher is just some set of text basically. To denote this, you may want to put the parenthesis here so that it knows that okay, dollar $Anand is one variable and higher is all the surrounding text. Um, so so you can now see like the how this rule will be applied and basically like why these two rules go hand in hand. So the other thing that we talked about was the stdin. Every time we use a standard in place of a scalar expected, the Perl reads the next line from standard in. So essentially we can ask it to read this any amount of text from the terminal by just using the standard in. One thing to note here is the line read includes the new line character. So if you want to remove the new line character, you will do a standard in and then immediately do a jump to get rid of the new line character. And then the default stdin, even though like you can see that this is actually a file handle, this is a terminal essentially. So you read in from the terminal and then you can do things with it. And then as I mentioned, basically almost always we chop the new line off after we read in the stdin. So this is the key things about the stdin. We also saw some examples. I'm not going to quote the examples. This is still talking about the recap. And then finally the undef value that we saw essentially. The undef is actually, you can think of it as a value, and that value is used before it is given a value. So before you give it a value, the value is what is the undef. Essentially it is not equal to 0 or it is not equal to a null string. So I think like that's one thing that you want to understand. Only like for the number operations the undef is treated as 0. So if you have any kind of a $A plus $B where the $A is not defined, then this will equal to 0 for this operation essentially. So otherwise like it's like not a 0, but when you perform an operation with that value, with that variable, then it is treated as 0. And it is also treated as an empty string for string operations. Again, this rule does not hold good when you perform an operation. And then stdin returns undef if there is no more data. So now we will start today's topic. I think like so this is fairly clear. We will encounter this undef in many programs in the coming lectures. I just wanted to again understand and keep in mind how to use undef. So today we will start our topic with the discussions on array and list data. Mostly we will be focusing on array today, and lists are basically we can talk about it in the next one. Again, what is an array? Array is an ordered list of a scalar data. In Perl, one good thing is like there is no declaration needed to define an array, and the size can be 0 to any number. Mostly like this number is limited by the amount of memory that is allowed in the machine, and we can easily increase the size of an array by just adding new elements to it. So we will see like how we can define the array and how we will do addition of arrays. So the array literal is a list of comma separated values enclosed in parentheses. So we will see like how to define an array literal. And then there are some special operator. One is this one. This is called the range operator. It has two meanings depending on the context, and we will see that. So let's first look at some of the examples of an array. So this is an array literal. Basically, it's the two parentheses, and then the values are enclosed within those parentheses, and they are comma separated. This is another array which has a string as one of the element, and then there is a number as another element. This is another array. If you define this, basically then the $A becomes the first element and 99 becomes the second element. Otherwise this becomes an undef or 0 when any operations get performed. This one essentially, like, I mean, it's just an arithmetic operator. With an array, and then this is an empty array of size equal to 0. And then we have the range operators 1 through 9. So actually here it will be like 1, 2, 3, 4, 5, 6, 7, 8, 9. That's your array. And in this one it's 1, 2, 3, 4, 5, 10, and 20. So you can think of there are commas on them. So now what will this array be essentially? So again here it's we will talk about the rules as to how this array is defined. But essentially, like, I mean, it will be like this 1, 2, 3, 4, 5, and even for this one it is 1, 2, 3, 4, 5, because it only takes the integer from the first and increments 1 at a time until it reaches the final number. So these will be ignored, this will be ignored, this will be ignored, this all will be ignored. So let's look at the two contexts that I mentioned for the range operator. So the first one is the list context, which is pretty much what is defined in here. All these 4 examples define the list context of the array. In the list context, it returns the list of values counting up by ones from the left value to the right value. So if the left value is greater than the right value, then it returns an empty list. So that is another key thing that to note. So but in the modern implementation, so like, I mean, if you look at some of the Perl books, the older Perl books, you will see like this one caveat written in that, where if you use this kind of a number like 1 dot dot 1 underscore 1000 1000, then it can burn a lot of memory because it creates an array for you, a temporary array for you. But this temporary array is no longer created in the newer implementations of Perl. So this statement, even though it is not a very good use, it's a safe statement. It's not a it won't cause any issues in this statement. The second context that I meant to mention is the scalar context. In scalar context, the operator dot dot actually returns a Boolean value. So it is like a flip flop. It emulates the long range operator of sed, awk, and other editors. This is the line range operator is also known as the comma operator. So each of the dot dot operator maintains its own Boolean states even across calls to subroutine that contains it. So the way it works is it is false as long as the left operand is false. Once the left operand becomes true, then the range operator stays true until the right operand is true, after which the range operator becomes false again. It doesn't become false till the next time the range operator is evaluated. So it can test the right operator operand and become false on the same evaluation, and it becomes true, but it still retains the true at least once. So these are all like big set of rules. Let's see like an example, because that pretty much gives us how this command works. So here is a simple scalar context essentially, where we use this number here 101 dot dot 200 print. So the way to interpret this command is essentially it prints the 200 to the second 100 lines essentially. So basically it prints from line number 101 to 200, but it is the short for these conditions, basically like dollar dot equal to 101 and dollar dot equal to 200 print. So the question is like this is another dollar variable. We saw like two of them before, and now this is the third one, which is the dollar dot operator. So the dollar dot essentially it's the shorthand for input line number. So essentially like what we're saying here is this 101 is actually the line numbers. So if the line number is equal to 101 all the way to line number equal to 200, print this. So here actually like this corresponds to the equality operator, but there are other ways of using the dot dot operator as well. So in the scalar context, so you can test multiple conditions and then come up with various answers for that. So now let's talk about the array variables. So we saw like the scalar variables actually they start with the dollar. The array variables they start with the ampersand or at. So since they have different prefix compared to a scalar variable, we can have the same name, but you can treat them as two different variables. For example, the ampersand a and dollar a are actually like two different variables. So you can use them interchangeably, or you can you can each will have its own value. So it's not dependent on one value or the other. Okay, so that is one thing. And the array assignment essentially where arrays can be assigned by using the assignment operator. The value of the assignment is the entire array. So how do we use this? So here are some examples. First of all, declaration of an array. We know that this is the way to declare an array, and then we assign a variable which is the ampersand a. And here this is a string array containing colors, the names of colors. So at color is red, white, and blue. And at b equal to 1, this is also a interesting array containing just one element. Here is another one. $C is basically 0 at a and 9. So this can be, you can replace this here so that it becomes like 0 1 2 3 9. And then the same thing, the gray is actually updated towards the end to the at color array, and you can see that actually it's used both places. And this is a multi-assignment case where actually like both dollar at E and at B are assigned same as color. So here, so one more clarification here, which is the one I mentioned basically is a single element array, so it's basically it will be promoted to like with the parenthesis, and so that it will be the it will be an array type. So here the same thing like 0 1 2 3 9, and then here again the gray is added to the end, and then this one is a both $D and $E are assigned the same color as the variable. So the array literal essentially like we saw this briefly, essentially like I mean if the literal contains only the variable references, it does not have any expressions or constants. The array literal can be just used as a variable. It can be used on the left hand side of the assignment. So let's see some array literals. So here $A, $B, $C equals 1 2 3. So what this means is essentially like the $A gets 1, B gets 2, and C gets 3. So that's defined here. And then the second command is essentially like $A, $B is equal to $B, $A. Even though you can see that actually like they are the same, this is what is called a swap. So we just swap the elements. So now the $A becomes 2 and $B becomes 1. So now let's look at that. The first $first and the $rest is $A, $B, $C, and 99. So the first is whatever will be the first, and that gets assigned to the $first. So the first is in this array, it's 1, so it gets 1, and then the rest is $B, $C, and 99, which is 2, 3, and 99. So here again, like I mean, we are not doing the swap. This is before the swap. So that's why like I mean it's still these values are 1 2 3 and 99. If it is applied after this statement, then this will be like so 2 will be assigned to first, and then 1 3 99 will be applied to the second, all the rest. Now you can also have an array followed by a scalar variable inside the assignment. So in this case, like I mean $all and $empty, essentially the $all contains the the ampersand rest. So or sorry, the ampersand all contains all of the elements from ampersand rest, which is in this case it will be like 2 3 and 99. And then the empty is essentially like I mean it returns this undef. So it has nothing in it, and it just returns the undef as the next level. So I hope like again this these examples illustrate how the array structure array literal can be used. So this will be again used in many programs, essentially used to collect information and then also like disseminate that information to the other sections of the program. So now another question is, how do you estimate or how do you determine the length of an array? The length of an array is determined by a scalar variable, and if the array variable is assigned to a scalar variable, the number assigned is the length of that array. So what does that mean? So you can just say basically okay $A equal to $or at A. So in this statement essentially like I mean whatever the number of elements in at A is assigned to $A. Actually it is slightly bit more complicated than that essentially. So this one now it takes the number the thing. So there's also a special variable which is dollar hash array. This is essentially like stores the upper bound of the index of in the array. What that means is the bound the index of the last element of the array is stored in this variable. So for example, in this case it will be like dollar hash a will hold the index of the last element. So typically the array goes from 0 to the index of last element. Last index. So usually we want to add 1 to the last index to get the number of arrays because it starts with 0. So that's the reason why, like, I mean, when we assign the dollar size to I mean the array, the whole array to the dollar size, the value of size is actually it's dollar hash array plus 1. So this 1 denotes this 1 that is needed to represent the 0th element, and then this will be basically the index of the last element in that array. So some examples here. So here basically the ampersand a is 1, 2, and 3. So now when we print just the whole array, basically it prints 1, 2, 3. Then it prints this square brackets also because they are marked as literals here. Now we want to print the size, and can you take a guess? So the size is actually 3 because that's what we got. And then the next one we are doing essentially we are just adding additional one more element which is last to the array, and then we are printing out that essentially with a square bracket beginning and the end. So now we get this, and then finally we have this size equal to ampersand a, which it should now denote size as 4 because we have added one more element to the array. So now the element array access itself, we kind of figured out that we can use it with the subscript operator, which is a square bracket, and then use the dollar for the subscript variable. The array subscripts typically starts at 0. We already saw that in this slide that when we ask for size is 3, but essentially it's denoted as this 1, 2, and 3. So essentially, like, I mean, it's that dollar pound or dollar hash array plus 1. So and if an array index is outside the boundary, the value is undefined. So this is one of the key concepts of why we wanted to understand what undef stands for in the very beginning. Now there are some examples. So the ampersand color is red, white, and blue, and $x is dollar color 0. So you can say what this has, and now the dollar color 2 is changed to yellow. So now and then here there are some more ways of accessing the array. So here actually, like, I mean, so one thing to note is, like, I mean, so this color 0 means like so $x is equal to red. Actually, yeah. And then here color 2 is yellow that means that color 2 is the last element of the array, which is blue, and then that is replaced by yellow. And here again, like so this is more like a string array. These are known as string or string array. Now let's look at these examples here. The array is declared as a numerical array, which is 0, 1, 2, 3, and then we increment the third element by 1. So that means that the 3 is becoming 4, and then we write out. So here we are doing like A1, A2 is same as A2, A3. That means that we are swapping it. So we actually have the array as 0, 1, 2, 4, and then now we are swapping the first and the second with the second and the third. So this means this will become like 1, 1 or 1, 2, 2, 4. And then if we print $A ampersand A minus 1, then it prints number 4, which is the last element of the array. That's because $A denotes the current value of the current array essentially, and then the current array is line number, and then ampersand A minus ampersand A itself is the number of elements of that array, which is 4, and then we minus 1 out of that. So this becomes $A3, which is essentially it goes and finds out the last element and then prints out. So the answer will be 4. So now we introduce another concept called a slice. Essentially, a slice is a shorthand representation to denote multiple elements of an array. So in this small example, ampersand A 1, 3, and 5 is essentially to the same as $A1, $A3, and $A5. The indices of the slice does not have to be increasing. For example, ampersand A105 is perfectly a legal one, and also it need not be different. It can be like just A111, which is essentially says that okay, the first element of all my file I want, or my array, I need the same value to be set 3 times. So if you look at here, essentially like say 0, so it will come as actually let's look at that. So this is the 0th element, this is the first element. So it will start printing just 1, 1, 1. Okay. So here are some more examples essentially. So $A is 0, 1, 2, 3, 4, 5. That's here, which is the actual array, and then we replace 1, 3, and 5, which is 1, 3, and 5. We assign the 2. I mean, actually, like sorry, 1. So 1, 3, and 5 will be replaced by 0, 2, and 4. So essentially, like I mean, so it becomes 0, 0, 2, 2, 4, 4 as the main values of this array. And then once you print out 4, 2, and 0, that is goes there 0, 1, 2, 3, 4. It prints out 4, 0, 1, 2, and then it prints out 2, 4, 2, 0. So that's what is denoted here. and then finally we ask it to print $A3 and @A3. So can you see the difference essentially, and then you can see how that will be printed out. In this case both of them are the same, so it prints out 2 and 2. $A3 is the same as here, and ampersand A3 is also the same. So one other key thing to note about the slices, an array itself can be used as an index of a slice. So here example is like $name, and it has the index of $even, which is also another array. So here is another example. $A is defined as 0, 1, 2, 3, 4, 5, and B is actually like just one shift to the left, which is 1, 2, 3, 4, 5, and then a 0. So when we print the $A, we get 0, 1, 2, 3, 4, 5, and then we say print A, and then in parenthesis is $B. So what will you get? Pretty much the same essentially, like so it will be used the B as the index, so you get the same results. Now what if like you use B once again and then try to print that essentially? So now it's almost as if like it's a shifter, so it's shifting to the left, so or essentially to the right. So the 2 actually like goes actually the 1 goes to towards the end, and then you get 2, 3, 4, 5, 0, 1. And then similarly like you can actually increase this ampersand B, and you can make it more and more as a shift register. So now the next topic is how to build array as a stack essentially. So a stack is you can think of like like a jar of say biscuits essentially. So the elements that you insert first goes all the way to the bottom, and then basically like when you are popping essentially like it only pops from the top. So all the elements, in order to access the last element or the first element that you pushed in, you have to access all the elements before it, pop out all of them, and then only you can take the last one. This particular kind of arrangement is also known as LIFO. I think this is quite familiar to many of you, which is last in first out. So how do we implement this kind of complex data structure? So one thing to notice when we talk about stacks, the stack is still aligned at the lower end of the array as the index 0. This is one key thing why we can easily access essentially like and then if it is not aligned, then the data can get corrupted. So what we do is essentially like we can push a list with the new element. So at list is the variable that holds all the value. So so this is one way to do it, is basically add list and then the new element, use the push command. This appends the element at the end of the array. So you have like 1 through say 5, and then when your turn comes, basically that gets added as number 6 at the end. So somebody has to pretty much like do memory management all the time to understand what is going on. The other main thing is the pop. Essentially the pop functionality is shown here, which is basically pop the list and then assign the top one to the $top. So you can think of it like this basically. So when you, this is for push, this is 0 1 2 and then vice and continues on. For the pop, you have this array 0 1 2 3, and then essentially the way to pop the thing is basically you assign a variable, and then this variable holds elements from the top. So first you need to clear the third element before you can do the second element, before you can do the first one. So I think like, I mean, that's pretty much this topic. Now shall we go into the so before we go into it, essentially let's do some examples again. So here is an example where the array is defined as 0 1 2 3 4 5, and then we have a new scalar $new, which is equal to 99, and then we say basically push this $new into the array A. So what that means is essentially like this is pushed towards the end. So 0 1 2 3 4 5 with 99 at the end. Now if you push two letters 6 and 9, 6 and 7. So now already it is changed to 99. So when we pushed 6 and 7, it became 6 and 7. Now let's look at the continue with the same example and into the pop section. We assign $top to pop ampersand A. So when we try to print ampersand A, it gives like 0 1 2 3 4 5 99 and then 6. And then we define another array variable called the $B, when it is assigned to 1 2 and 3, and then we do a push $B, I mean ampersand B to ampersand B. That means that you concatenate this at least 2 times. So we get 1 2 3 1 2 3. Now if we push another array 7 8 9, that array will be like all these constructs are lost, and then there is basically it has a longer array now 1 2 3 1 2 3 and 7 8 9. So let's see some examples. So here we have a declaration where ampersand A is 0 1 2 3, and then $A we defined it as 99, and then essentially like, I mean, so the result of this statement is 0 1 2 undef and then 99. So now the $top is defined as we want to pop stuff from ampersand A, and then so that was successfully done, and then we say basically okay, print the pop to the top, and that prints out this information 1 2 0 1 2 and then undefined, and then top equal to pop, and then pop stop, this will print out 0 1 and 2. Okay, so we will also like go through the lecture for shift and unshift. So the shift and unshift is very similar to the pop-up. We say basically the this is the beginning of the array basically. So this is the beginning, this is the end. Essentially, like, I mean, now you have another partition here, and you basically like memories they are going away essentially, like and then contractors. Um, so in this one, essentially um, so um, the way this will work will be basically that each element is pushed into the array. So whereas in a shift, actually, so you can think of this as um, the so the push operation essentially, like pushes the existing elements down and pushes at the front. So this is the beginning and this is the end. So everything is pushed to the end. So and then the pop is it's back the same way. Whereas a shift operation essentially it it's on the lower end of the array essentially, like so the index of that will be the newer index essentially. We will see some examples here. So the array is defined as 99 0 1 2 3 and then we shift the array and then the result is essentially like 0 1 2 3 because now this 99 essentially goes into the B essentially. So $B becomes 99 and then the array stays the array has 0 1 2 3 and then when we say like unshift that particular element then it's back basically, like it's pushed into the array and then it's brought back. And then if you say like unshift 4 and 5, so those 4 and 5 are added at the beginning of the array, so it is 4 5 9 9 9 0 1 2 3. Some more examples on the shift. So if you say like unshift $tag, the tag is defined as last and then that gets added as as the first element of the array. And then if you do an x $x equal to shift ampersand a, then the last gets assigned to the shift assigned to the x and then the array becomes just 4 5 99 0 1 2 3. So I think I'm going to stop at this point. We will talk about the reverse, the sort and those type of functions in the next class. And again we are still talking about the arrays themselves basically. So arrays are a huge data structure and it's used everywhere and in everyday life. But we have like very little information about this functionality and that is one thing that we covered today. I hope this is quite useful. So what we talked about, I'm just taking you back. So we started our discussion with an array. We understood how to declare an array and also like we saw how operations can be performed on an array. We understood how to get the length of the array and so that we can act upon it. We can do other things with the length. Then we also went through some of the ways of creating an array. Creating an array and then how to use stacks and the shift registers or shifters basically. So I think that's all for today. We will actually continue from this point in the next lecture. Until then, thanks for listening. Thank you very much.